Hey! In 2 minutes, we're going to go through a basic setup on Autodesk CFD 2019. We're going to show importing a part, creating external geometry, assigning materials, boundary conditions, and then a solution. We'll take a look at some ways to view the solution, and we'll do this in 2 minutes. So here we go. We're going to have a new design study, browse, we're going to bring in our model. We'll bring in this one this time. And we're going to call this design 2 and create. So now it's going to create our design study. Again, we're going to ignore this warning here. Just for now, we're going to do that. Now, we're looking at flow through a long rectangular pipe, so we'll make our pipe long. We'll make it a little bit bigger than our part here. Again, we're not being super precise here. I don't know how to make a cylindrical external volume in this software. I'm sure there's a way to do it. Google it. Alright, tell it create. Close that. And let's tell it edit. So the part that we brought in is a solid. ABS is close enough. The part that we created is a fluid. It is water. Apply. Next. So we've assigned materials. So we created external geometry, assigned materials, time for some boundary conditions. We're going to tell it that the walls of our pipe here, that our walls are slippery, so the water is not going to have any friction with the walls. We're going to tell it here that this water is flowing at 2 meters a second, nice and steady, and that here, that we don't know, so we're going to let the software come up with what's going on there. Next, we're going to go to initial conditions. We're going to leave that alone. We're not going to deal with any motion on this one, and we're going to, if we wanted it to spin, this is where we would set that up. Instead, we're going to leave it alone. We're just going to tell it to saw. We're looking for a steady state solution. We'll let it run 100 iterations and go. And now it's creating a mesh automatically. It's splitting the spile up into the part and the water up into little tiny bits so it can calculate what's going on. And in a second here it'll start calculating. Alright, so now it's calculating the water flow as it goes through here. And you notice right now greenish is 2 meters a second. So you see out here at the inlet we have greenish 2 meters a second. And let's switch our water so that way we can see. That's right. Alright, so you'll notice down here we have our plot, our convergence plot, and we're looking to see that these results settle out. It's calculated 15 iterations so far. Right now we're looking at a global result. We're seeing velocity magnitude as our result. We can change this so that we see the part inside there. We'll also add a plane, so on planes, add a plane. We're going to edit that plane so that way our plane shows 90 degrees, and there's the flow around the part. And we can also see there's our flow around the part, and for now we'll leave that there like that. So we can also look at the wall calculator. So we want to calculate, let's suppress this volume real quick, just show the outline of the part so that way we can see. Sorry, let's let it finish calculating. I'm rushing things because I'm afraid I'm going to run out of time. It's wisely not letting me have it run a calculation while it's still running. So, at the very least, we have a simulation. It's running. This will run until it hits 100 iterations, or the software decides that this result over here has converged. We're seeing a big change here, so that's interesting. We're certainly not done calculating yet. Once this settles out and we stop seeing big changes, then we'll know that we've reached our result. If after 100 iterations we're still seeing big changes, we can tell it to go ahead and run some more iterations. Now we'll also turn on our global velocity vectors, actually, so we can see how the water is flowing around the part. It got real busy. Let's go over to our cut plane here. Let's turn the vectors on the cut plane. We can change some settings on the vectors there. We can make them really finely spaced so we can see what's going on, and we can give them a range of lengths. So the smaller ones are smaller and the bigger ones are bigger, and that will help us as we view our results in the end. So I'm going to stop my video here while this is still calculating. Notice it's only done 67 iterations, but we have it set up and running. And there we go.